right. Hello, everyone, and welcome to the Army of Women Researcher webinar series. My name is Nikki Larita. I'm the research manager at the Dr. Susan Love Research Foundation, and I'm excited to be hosting this session today. Before we get started, I'd like to thank everyone for joining us. Thank you, Joan, for taking time to teach us about the work you've been doing. We also have Dr. Susan Love, our Chief Visionary Officer, as well as Leah Ishraghi, our Clinical Research Director, here today. For members who are unable to make it, we're going to provide a recording of this webinar on the Army of Women website. Today we're going to have a conversation with Joan Severson about her work on two studies, the REFLECT study and the Brainbaseline CARE study. Questions during this webinar will be facilitated by Dr. Love. Before we get started, I'd like to introduce our researcher. Joan Severson is co-founder and president of Digital Artefacts. She works with a multidisciplinary team of designers and developers to integrate computer science, engineering, medicine, and human-computer interaction to develop a wide range of technology for everything from cognitive assessment and behavioral modeling to scientific data visualization. The work of Joan and her team is expansive and very collaborative in nature. She has worked on several exciting collaborations, including projects with the National Cancer Institute, Howard Hughes Medical Institute, MIT, among many others. I have a few housekeeping items to cover about this presentation and the GoToWebinar platform. First, if you have questions throughout the webinar, please send them to us through our questions tab, which is located on the side of your screen. We'll have some time at the end for questions, so we'll make every effort to answer as many questions as we can. And again, finally, a recording of today's webinar will be available shortly after the call. So with that, Joan, you can start your presentation.
Thank you. I'm honored to have been invited to present this work that we've done with a number of our collaborators that are listed here. One of the things I would really like to emphasize is that this type of work is really facilitated by truly multidisciplinary teams. So if you look at Digital Artefacts, our team is comprised of software engineers, animators and illustrators, as well as people with backgrounds in human factors and HCI, which is HCI is human-computer interaction, kind of a subset of human factors. And then the University of Illinois Champaign-Urbana, their group provided leadership in the areas of kinesthesiology, cognitive neurosciences, and basically they did most of the actual analysis that was done on the REFLECT studies data. And we worked with the University of Nebraska Medical Center, and that team, those team members are comprised of neuroscientists or neurologists, as well as people from oncology and from the clinical care teams. And then Joshua Cosman, who has worked with us since he was actually an undergraduate at the University of Iowa, has continued to work with us as he's translated over from postdoctoral research at Vanderbilt, and then he was with Pfizer when we were working on this project. So I just wanted to thank and kind of illustrate the expansive domains in which we work in order to be able to do this type of work. And again, I'd also like to thank the Army of Women for making this study possible, and I'll be able to demonstrate that here in a few seconds. So our first study that we did examining the relationship between breast cancer survivors, lifestyle, behavior, exercise, and sleep, and cognitive function was started with the University of Illinois Champaign-Urbana. That study was entirely conducted on an iPad. And I don't know if, and it was conducted on an iPad, and the entire study population was recruited through the Army of Women. So no study participants were ever physically present with researchers, and they were able to conduct the entire study in a naturalistic setting in their home, typically, is where we believe people were actually administering the study. This study was, I think, maybe the first iPad-based Apple Research Kit study. So we had just started preparing to do the study. We had done some previous work with Art Kramer at the University of Illinois looking at cognitive testing that was self-administered outside of a clinical setting, and its validity and its utility in research. And we've done some publications and So it came back where we were able to demonstrate the testing that people had done unsupervised in their home was equivalent in terms of where we were expecting their performance to be based on age and gender and other demographic factors as the measures that were collected in a supervised clinical or laboratory setting. And so from that, we decided that we would try to actually conduct a study that was examining something more than just cognition. So Annie McCauley is an exercise kinesiologist, and Art Kramer he was the director of the Beckman Institute. He's now at Northeastern University. I think his center there is a cognitive aging research group. And they've both done quite a bit of research looking at how exercise actually affects cognitive function and can be used to reduce the effects of aging or other forms of aging and disease. Those are two different things. So, so this study was piloted with by recruiting subjects solely through the Army of Women. We used the Apple Research Kit framework to do the HIPAA compliant and IRB reviewed consulting and consenting. I apologize. And it was a very successful study. We had over 500 participants. A little over 400 people completed the entire protocol. And it was a pretty extensive investment of time by the participants from the Army of Women. They, the people that completed the protocol completed, I believe it was 10 different testing instruments, self-administered, and they completed over 200 survey questions that covered topics such as, you know, if they were in a menopausal state, what types of medication they had been administered through their breast cancer treatment, if they had received radiation or surgery, what state they were in terms of if they were in remission. They were, I mean, there was a lot of data that was collected in through the application that typically would not have been accessible to researchers without a great deal of effort recruiting subjects to come in. I think one of the things that was very surprising in terms of how many people participated and completed the protocol is that typically to get about 500 subjects into a study, it would take several years to bring them in in order to have them participate. So you would recruit, you would bring them, you would consent them, you would screen them and consent them. And that is a great deal of effort in not just the amount of time, but you know, there's a great deal of cost associated with it. So this study was very successful in terms of being able to demonstrate that people would adhere to a protocol and that the data would produce meaningful information. From this study, there have been from the data, there have been a number of analyses that have been performed in peer-reviewed publications, as well as presentations in peer-reviewed programs. But what was revealed in this study is that it appears that moderate to vigorous physical activity appears to have a positive effect on breast cancer survivors' performance on cognitive tasks, measuring speed of processing, working memory, and executive function. So it was very exciting to see this because it indicates that there may be something that could be done behaviorally that may be able to have a positive effect on the quality of life of breast cancer survivors. A second study was conducted. This time it was performed using the Apple iPhone. The reason for that was that they were hoping that they might be able to recruit more people that were from minorities or demographics with a lower socioeconomic background because the iPad is typically, the use of the iPad or access to the iPad appears to skew to higher education levels and primarily Caucasian and upper income level women. So the second study we conducted on the iPhone, it just closed recruitment. That study, I just wanted to show you that the iPhone provides a nice interface in order to be able to access the survey instruments and the assessments. Again, this is using the Apple Research Kit framework. And so there's a IRB approved consenting process. Subjects are able, they're presented with background on the study. Their data is completely de-identified when it's analyzed. It goes back to a HIPAA compliant environment where identifying information and the actual data collected in the study are completely separated through physical hardware. The cognitive tests, so if you look here on the surveys, again, this study also had an extensive number of surveys, questions. I think it was, again, probably another 200 questions. And then the testing instruments were presented. I believe there was they were asked to do testing on more than one occasion. So the iPhone provided us with the ability to actually send them a message to return to the study. And you can see that they were asked to take tests in 5 different, they were asked to self-administer 5 different testing instruments. And I'll go over what those testing instruments measure in a little bit here. This is an example of what a testing instrument looks like on the phone. This is the Stroop test. A lot of people may be familiar with this. And in this test, it measures your attention and executive function. And what it does is it presents a word, and the word is presented in a color, which would be, in this case, it's incongruent. And so the word is blue and is presented in red. And what we measure is essentially how quickly you respond and whether that response was accurate or not. Those 2 studies informed our ability to respond to an RFP from the National Cancer Institute that requested companies apply to develop a electronic platform for measuring cognitive assessment in cancer patients. When we saw the release for the RFP, we were stunned. We'd never talked to them. And it was exciting to see that they also thought that this was an area that was important. In the literature, basically, there are many, I have friends that have gone through breast cancer, and many of them have expressed concerns, and they call it chemo brain, or kind of a fog while they're going through their treatment. And I didn't realize until we actually started looking at the literature that 75% of patients report cognitive impairment during their treatment, and 35% of patients report impairments at least 1 year, up to a year after their treatment. So even though these, I mean, was pretty stunning to me, they think they're underreported. So, you know, there's definitely a need, and the National Cancer Institute was aware of that. So what would be the benefits from developing a platform that you would be able to measure cognitive in cancer patients? Well, we would be able to improve treatment options if we can actually measure. We might be able to develop better pharmaceutical therapies that have fewer side effects or could address the cognitive effects of cancer or the treatments for cancer. And basically, this type of data, the way that we've architected our system, can be used for epidemiology and other research so that they can better understand cancer-related cognitive decline, not just in the you know, the studies that we've conducted, but also be able to provide this data to other researchers and be able to link it to other sources of clinical and even genetic information. So our phase 1 in the study involved development of a software platform because it wasn't just designing a mobile application. We wanted this data to be able to be integrated into a clinical environment so that it could be used with cancer patients to actually, hopefully in the end, improve their quality of life. So we started out with designing a battery of assessments that could be capable of detecting neurocognitive impairments that are associated or have been reported to be associated with cancer. And then we built out a platform that would address integration with electronic medical records. And then we studied the usability of the tool that we prototyped in phase 1. So there are basically 2 main user interface components here. There's the clinical dashboard that's web-based, and then there's the mobile application that currently is designed to be used for studies, but it could easily be modified to be used in a clinical setting where oncologists that we actually worked with oncology team members at University of Nebraska Medical Center's Buffett Cancer Center, and they were very interested in being able to help us to provide something that could be used to be administered in the clinical setting, possibly like while a patient is waiting, as well as something that could be taken home by the patient or downloaded by the patient so they could collect continuous or additional data outside of the clinical setting. So the first components so basically we developed a website for the study so that we could provide information to people that were recruited through the Army of Women. The Army of Women did all of the recruitment for us, and then they were pointed to the website to get more information. And then once they, were presented with more detailed information through the website, they could then download the application through iTunes. And once they downloaded the application, they went through the research kit protocol for Apple Research Kit protocol for informed consent. And then they were assigned to 3 different cohorts in the study. And then that was done through the software. The software would assign them randomly to group A, B, or C. And those groups had different protocols that were administered through the software. So one group, I think they were requested to do the testing once a week. And I think another group, it was just once a month. They had the same types of questions, but this is one of the things that's very exciting about doing mobile-based cognitive or mobile-based research is that the software can essentially provide the ability to interact with your study subjects in a way that just is not possible when you have to bring them into the study environment. So what we had is the iPad application went from consenting, it then assigns you to schedule A, B, or C, and then there are 2 main sections to the home page or the dashboard. It's very simple. We didn't provide any feedback. So typically like in some studies, the dashboard will actually provide users with feedback on how they're performing against themselves or other people that are participating in the study. But we didn't want this to potentially alarm people if they weren't performing well on some of the cognitive tests. But so the survey instruments, this is when you click on this page here, it would take you to the survey page. And then the surveys, we had 8 different surveys that were available to the user. We take them through in an order. Same thing that would happen like if you were in a clinical research setting. They would administer the protocol in a certain order. So basically, once you've done this survey, it would unlock this survey. And then going into the cognitive testing element here, it would take you again to the cognitive testing platform. And because again, we wanted to be able to have people presented with the testing instruments in a specific order, each of the tests would unlock as you completed them. And so, there were 2 main components to the mobile application, the tablet application, the survey and neuropsychological assessments. On the neuropsychological or the cognitive assessment battery, we had 11 different instruments that measured aspects of visual search, is speed of processing and working memory, verbal learning. This task here actually used you use voice, and it will, we actually use natural language processing algorithms that were able to record your voice and score based on what your response is to what the a list of words that are presented to you, and then you're asked to recall them. And then and then there's a second piece to it. So this part, you're learning it, and then this back here, you're asked to recall what you learned after you've gone through the entire series of tests. The Posner task looks at inhibition, executive function, and speed of processing. I don't know if I have, let's see here. Oh, the Posner task is attention and processing speed. So these tasks are tasks that have been used. A lot of them have been around for over 50 years and were typically only available in laboratory settings, or were paper pencil based. So a lot of these tasks, like the task switching task, were developed at the University of Illinois Champaign-Urbana, and they had used them for over a decade in different studies. When we first started developing these tasks, so like if you went into a laboratory at the University of Illinois Champaign-Urbana and you did this task switching task, which basically you're switching between indicating whether the number is above the value 5 or below the value 5, and whether or not it's an odd or an even number. We can give you a demonstration of that later. But typically, when you're in a laboratory setting, you would need to do this test 300 to 400 trials. So that means that you would have to do this for about 10 minutes in order for them to get good, reliable measures. We've been able to demonstrate that by using a touchscreen environment, like on an iPad, and by going through, we have a process of practice and feedback for training somebody on how to do the task. We're able to get these tasks down to about 1 minute to 2 minutes and get good data that can be used for these types of studies of assessment. We're also able to use these tasks. They've been designed so that you can repeat administration of them. So that means that some tasks you can only be, so for example, a cognitive screening tool that we might all be familiar with would be the MOCA. That's the Montreal Cognitive Assessment. That's the test that was used, I think recently for President Trump's health screening. That task can only be administered, I believe, once a year, because you would memorize what the task, you're not supposed to have been exposed to the task prior to taking the test and being scored. Our instruments are designed so that you can be administered the test with a frequency of at least once a week, with I think no more than once a week. And the stimulus is never the same. So what we're trying to address there is training effect, and we're able to then, by presenting the testing to people with frequency, what we're able to do is potentially get them to reach an asymptote. So we know this is really measuring your abilities in speed of processing or memory. We're not measuring your ability to do the test. So that's why, like previously, you'd have to do 300 or 400 trials, because the first 100 trials, you're trying to learn how to do the task, and they throw that data out. The last 100 trials, you're so bored, so they look for where you hit the asymptote, and then the last 100 trials, you're so bored, they basically throw that data out. So they have a sweet spot, but you're subjected to having to do testing for a very long period of time. So let me, I can provide more details about these tasks, but VST, so the visual search task measures attention and speed of processing. The verbal learning task looks at long-term memory. That's with the verbal recall task. The Posner task measures attention and processing speed. The task switching task measures executive function and processing speed. The Stroop task measures attention, executive function, and processing speed. The VSTM, it's the visual spatial task, measures visual spatial processing and working memory. The paired associates task measures memory. A visual spatial processing and visual long-term memory. The flanker task is designed to measure attention and executive function. I've done that one here. The NVAG task looks at working memory and executive function. And the fine motor task is one that looks at motor control and visual spatial processing. And this one can really only be done on something like an iPad, because what you do is you put 2 fingers on the green disc, and you basically, you move it over into place, never lifting your fingers, and you rotate it. If you were in a clinical setting, this is the way that they measure fine motor is by using little pegs that fit into a groove pegboard, and you have to rotate and manipulate those to put those into the pegboard. So we were asked to, several years ago, design an instrument that could be done on a digital version of it. And so this task has been used in a number of different studies looking at motor function. So I'm going to show you a few of the tasks. I think some of these may not actually be in the list that I showed you, but the flanker task is one of them. And this is what a task looks like when it's presented to a user on the iPad. And this is a recording of a practice session. So when you would actually be administering the test, whether you got it correct or incorrect isn't presented to you. In this task, there is an arrow in the center of the 5 arrows, and you need to hit either the left or the right button indicating which direction that middle arrow is pointing. So it's a pretty simple task. It takes about, I think this one is, I think it's 60 seconds for the entire trial. This is the digit symbol substitution task. I think we didn't actually use it in the study. We had over 50 different testing instruments that we developed for both the iPad and iPhone, as well as the Apple Watch. And our testing instruments are used in a number of different studies where they're using them in looking at HIV-associated neurocognitive disorders. They're using them in Parkinson's studies. They're using them in a number of different human factor studies and examining other diseases. MS is another one. So in this task, digit symbol substitution, what it does is, this was originally a paper pencil based test. And what you're doing is there's the key at the top, and you need to be able to quickly drag the symbol that matches to the number below it. We also have a voice-based version of this task where the symbols are presented, and you need to, when it's slowly presented to you, you have to recite what number matches it. So this paper pencil version of it is a sheet of paper that has 100 symbol digit pairs on the sheet. I think it's 100 of them, and you have to go through them from top left to right as quickly as possible, filling in the numbers. The reason these types of tasks are so appealing, not only for these types of what we call virtual or mobile studies, is that they're all scored automatically, and the data is put into databases automatically. So we save a lot of money in terms of the amount of time that it takes to score the test. We also have consistency in terms of the presentation of the test. There isn't, people respond differently to, like, even the person that is providing a testing instrument to someone. This test here is the Trails A and B task, and it's basically your the B task. There's letters presented, so you would go 1 to A, to 2 to B. This is just showing the Trails A. It's like a dot to dot. You're not allowed to pick up your finger, and they look at accuracy and time to completion. What's interesting for us with this is because we have a digital version of it, we can now do further analysis looking at what type of a trail you produced. Did you find the optimal or shortest route in order to get between the different dots? And this is another test where you can take this test up to 50 times and not be presented with the same trail. So that's what the cognitive testing portion of the instrument looked like on the iPad. The clinical dashboard was requested in the development of this platform so that the data that is collected through the tablet can be presented in a meaningful way to clinicians. So it's interesting that in this day and age, we do not have a cognitive medical record system. And I say which addresses measuring and monitoring cognitive function, quality of life, and mood over time, but we actually do not, I don't know, I've never had a neuropsych test administered in a clinical setting. Typically, they're not administered unless there is, a head injury or a reason where, they suspect that there's something wrong. So we don't have cognitive baselines like you would with your blood pressure. Your blood pressure, you know what your blood pressure is pretty much at every stage of your life, and we know what would be considered normal for you. With cognitive function, we don't know what is considered normal for you. So this is something where, if this is successful, we'll be able to potentially be able to provide, a baseline measure of healthy individuals, as well as be able to monitor cancer patients as they go through their therapy. This was designed with clinicians, and one of the things that we were told is that they wanted to have something that they could actually talk to the patient with. So a lot of times if you go in and you look at like an Epic medical record system, that system isn't designed for the patient to look at those screens. What they wanted was something that they could actually talk to the patient about how they're performing over time. And then I don't have a close-up on the screen here, but we actually have, so there's a way to link it to the medical record, but what they also asked for were patient education tools that they could provide to the patient to counsel them on lifestyle, nutrition, physical exercise, and sleep that could have a positive outcome or have a positive impact on some of the cognitive issues that their patients have. Talking to the oncologists, they would not change their protocol for how they would treat a patient in terms of what medication or therapy they would have. But they typically do provide counseling in terms of things that we believe may have an effect on cognitive function, such as getting sleep and exercise. So this study was, again, it was the entire recruitment was conducted through the Army of Women. We are very pleased with considering the number of testing instruments that we presented to people, how many people actually completed every survey, and how many neuropsych tests that they performed on their own. So one thing that I just can't emphasize enough, I think, is that being able to do a virtual study like this, this entire study, from the design of the instruments, including the dashboard and the mobile application, to recruitment with the Army of Women, and then having subjects self-administer the study protocol through the mobile device, and then data analysis and reporting. The entire study was conducted in 12 months. And, excuse me?
Oh, we're just saying, wow.
Oh. we impressed we were just real, well, first of all, one of the hardest things with one of these studies is recruiting subjects. And so the Army of Women was truly instrumental in the success of this study, because it is very difficult to reach out to people and, let them know that this is a trusted study, but to get people that are also, they're engaged. I mean, the Army of Women clearly demonstrated that as research subjects, that they were good study participants. They performed the study for us. So what we're looking at here is over 163,000 neuropsych tests were self-administered. So all of that data can be used by researchers that we're working with to analyze, and that's what they're doing, is they're going back and they're looking at that and they're comparing that to self-reported survey information that was also collected in this study. So, there's a total of almost 30,000 survey responses and almost 200,000 data points were collected in this study, because each of those tests, each trial has performance metrics in all of them. And so we did multiple analysis, and I'm just going to present a little bit in terms of what we looked at. And so one of the things that we looked at was the effects of physical activity and age on cognitive function. And this helped us to look at the validity of these instruments in terms of, did they actually collect or align up with what we have observed in our clinical or our laboratory research? And they do. So when we're looking at visual short-term memory and age, their visual short-term memory accuracy declines over time. If we're looking at task switching by age, that cost actually goes up with age over time. When we're looking at exercise, the visual search, people that report that they exercise more, their visual search times are actually lower. So that's better performance. Again, with fine motor skills and exercise, we see that their performance is actually better because they're able to perform the task accurately and more quickly. So, you know, we went back, and with this is a pilot study, and so we wanted to look at the quality of the data. We were able to compare that data to data that we had been collecting over a number of years in different studies. And so one of the other analysis that we did, many different analysis, but this one I put up here so that you can kind of see how we were able to take that survey data and apply it to the cognitive function, the cognitive testing instruments. And we could start to look at what aspects of cognition or quality of life, and so if you look at, you know, these are in our surveys, we weren't, you know, there's a lot of surveys about time management and things that we would call quality of life questions, and we were able to compare how they perform. So people that have time management issues appear to also did poorly on the NBAC test, which is the memory task. And so you can kind of see where we created this little heat map where we could, you know, look at where the cognitive testing and depression or fatigue and sleep and exercise relate to each other. And again, there's so much data. This is just like one sample of like how we did an analysis with looking at the survey and lifestyle information on the cognitive function. One of the values in having done this type of mobile cognitive testing for a long time is that we have a very large normative data set. I think we have almost 100,000 people that have self-administered cognitive testing on the Brainbaseline platform. And so what we did was we pulled subjects that matched the cohort from the Army of Women, and we're able to compare their performance to, so we were able to compare the Army of Women cancer patients to our normative data. And what was interesting there, and when we compare them, we look at them by gender and we look at them by age, but we also look at education level because that seems to also have an influence on your performance on cognitive testing. So what was really exciting here is that, and I didn't share this in there because it's something that we have in review, is that we were able to develop a global deficit score, which means that what we're doing here is we consider their the severity of impairment across all of the measures. So we're not just looking at one test or one individual. We're looking at, we can look at an individual and how they compare when you look at the multiple domains of cognition. Again, I want to emphasize I'm not the neuroscientist on the team. So I'm presenting our group's findings. So I could bring neuroscientists in for another meeting and he'll give you more details on it. But the global deficit score analysis indicates that a subgroup of patients may be more impaired than both other cancer patients in healthy comparisons. That's where we would probably say those patients are experiencing chemo brain, or that there's something else going on. So those are, again, this is early data to be looking at, but this type of data has never been collected before at this scale. And this was a study that was a 12-month study. It wasn't, you know, it was a pilot study, but this is, you know, we feel like these types of studies, being able to do virtual studies, we can gather meaningful data that will potentially have a tremendous impact on us quickly understanding what's going on regarding chemo brain. So in our phase 2, we'll be improving our technical capabilities, and then we'll be working with the clinical team at the Nebraska Medical Center's Buffett Cancer Center. So what we want to do is, now we know we can collect data in the wild, and now we want to be able to collect data with clinical patients and look at that data along with we will not look at their medical record information, and we can start to, I call it ground truth, and hopefully we'll be able to develop, be able to identify and measure chemobrain, and then be able to identify ways in which to treat it. I think that's it.
Wow.
Thank you, Joan. So now we'll take some questions. As a reminder, you can still submit questions through the questions pane in your attendee control panel. So our,
I wanted to start, yeah.
oh, okay. No, we'll have Dr. Luff give a few thoughts first.
No, I was just going to say I have some questions to start. Do you think that people might be more anxious taking the test in the clinic than at home? I mean, do you think you might see differences because of the setting?
Yeah, well, that white coat syndrome, just like with blood pressure.
Yeah,
I think so. That's what's interesting with this data is we can actually look at how people perform in a clinical or a laboratory setting, and we can look at it at home. We have a number of studies right now that people are doing where they're trying to look at that as well. Like I said, there are people that we're working with that are looking at Parkinson's disease and motor function, cognitive function. So I think that's, definitely something that we'll probably observe is that when you give people the opportunity to, and that's part of the HCI part, we try to design something that provides them with instructions and practice, and the actual testing that has video embedded in it so you can see how to do the test, and it has a narrator that tells you how to do the test. So, and we let you practice so that you feel comfortable with the test, and then you get to start the test. So we think that not only being in the comfort of your own home, but then the use of like an iPad, which is a pretty user-friendly touchscreen environment, has many different modalities of interaction where we can use audio, we can even use the camera for some things, and then the ability to let people, to be able to do testing over time where, we can get multiple, you may have a bad day. I mean, that's one of the problems with having an appointment to go in for your neuropsych test. You may not have slept well that night, and so you're not going to perform well. Does that make sense?
Mm-hmm. Yes, so, absolutely. No,
yeah.
I have another question too. That one of the things, because it's interesting that you didn't see a uniform effect. You saw a subgroup that's more impaired than others. And one of the things I've been thinking is that there probably are SNPs or genetic things that make you more susceptible to some drugs than others. Just the precision medicine that we brag about is good for treating cancers, but it may be we may need to be equally precise in terms of the collateral damage.
Yeah, no, this is definitely the idea here, and that's why we built a platform, is that people will be able to take the de-identified data and be able to link it, or if they have identified people in a study, they'll be able to link it to genetics, treatment protocols, outcome. I mean, this is the potential to look at how cognition, lifestyle, and behavior is influenced by all of those factors that are being collected or observed in a clinical setting.
Yeah. No, this is great work. It's really great work, and it's great to see our experience of chemobrain actually documented.
Oh,
it's not all in our heads.
Yeah, and the other thing is that this was a fun study to do. We were excited because we got so much data, and I can't again express that we could not have done this without you helping us with the recruitment. And
we're excited to help. I think we have some other questions. Do you want to?
So we have a couple of questions from our membership. The first is, did the team collect or consider whether people had any pre-existing cognitive impairment like ADHD, and if so, how is that addressed?
There are survey questions. I'm not sure if they totally, I think that we may have asked some of those questions. Have you ever been diagnosed? We do depression screening in there. There are other sort of cognitive questions regarding psychiatric conditions. So I don't know if they specifically asked for ADHD, but that's, you know, one of the things that we can easily put into there is self-report as part of the questionnaire. Yes.
Okay. For the next question, would you clarify whether these surveys were standardized surveys like the Promise Scale, or if these surveys were specifically developed for the study?
There were a number of, I think there are some surveys that we got permission to use, like I can't remember what PDQ. There are the researchers that we worked with helped us to select the surveys that are in this study so that they could be compared with other studies. So some of the survey questions were developed by our collaborators, and some of them are standard questionnaires. Like I know that, like, for example, our demographic questionnaire is one that is used in all of Art Kramer's exercise studies. So we look at other things, you know, like, you know, how much do you watch television? How do you play video games? You know, we ask demographic questions, gender, age, education levels. I think we ask income information. But I mean, I know that for the first study for REFLECT, there were over 200 survey questions. But yes, some of them are standard questions. And we actually used a number of the questions. I forgot that they're on the NIH, I think the Promise site. So the NIH now provides a bunch of standardized survey questions.
So my next question was, will this app eventually be available on non-Apple devices, like an Android device?
We're just so we have over 50 different types of instruments, and we're starting to work with groups that have requested that we port our instruments over to Android. And we have 2 that are coming out. We're working, we've worked on a number of different studies with Sage Bionetworks up in Seattle. So the challenge is that every instrument that you release on, you have to test on that hardware and the software combination. So what's really nice with Apple is that the hardware and the software are essentially linked together. And we've also found that some of the screens on some Apple, on some Android devices have a little slower response time. So there's a lot in Android. There are a lot more combinations of operating system versions that people are still using out there, and a lot more combinations of hardware that are available. So that's the reason that we haven't moved over to that to Android yet.
Yeah.
So the next question is in regards to the Apple Research Kit. Does the Apple Research Kit manage the informed consent process or HIPAA form, or is that something that you had to build or code yourself?
No, that's where we originally were going to do that ourselves, and then Research Kit came out, and we were like, wait a second, let's use this. And so they did a very nice job of the consenting process. And so if you, I could probably bring up some, but the informed consent process is very well done, and we use that framework in all of our mobile studies. And that includes, you can withdraw from the study, you can download the entire consent, and who's running the study. It's basically, I've worked with a lot of research labs where they bring people in, they screen and consent them in the Research Kit framework also allows us to screen participants before they are fully admitted into participating in the study.
Very interesting. And it looks like we have one final question. So one member noted that would be interesting to see how specific treatments affect chemobrains. Did you collect information on specific different treatment options?
In the first study that we did with REFLECT, we did ask, and I'm not sure, I'd have to go back and look at the platform development study, but the first study, we asked which types of chemotherapy they received, which specific drugs they were administered. We have a menu of different drugs that are commonly used for breast cancer. treatment, whether they had radiation therapy, how long it was. We even asked them, you know, like about their sleep patterns. I mean, we asked them everything so that they could go back and, I mean, and they have years of opportunity. They have years of data to go back and try to look at those relationships. But that's another thing that, you know, like for pharmaceutical development or for clinical trials, you know, you could say this is the patient and we are doing this patient is using this drug, and we can essentially in real time monitor how they're being affected by it. We've done studies where we get analgesics in surgery and watched its decay rate over time based on cognitive testing administered every hour.
Yeah.
Got it. All right. So that's all that I have for questions right now. If you have questions that we didn't get to today, or if you think of new questions, please feel free to contact us at connect@armyofwomen.org. Again, we'll post a recording of this webinar on the Army of Women website in a few days. And so on behalf of the Army of Women and Dr. Susan Love Research Foundation, thank you so much for joining us today, and have an amazing rest of your day.
Thank you so much.
Thank you.
Take care.